Hello everyone. Today I will talk about what is a queue, implementation of queue, circular queue, deque and priority queue. Let us start with what is a queue. Queue is a FIFO, first in first out data structure, since first element in a queue will be the first element out of the queue. In other words, we can say that the order in which elements enter in a queue is the order in which they leave. As we know, a stack is a LIFO data structure, means last in first out data structure. In a stack, addition and deletion operations are performed at one end, and that end is called the top of the stack. Means push and pop operations are performed at the top of the stack. But in a queue, the elements are added at one end called the rear and deleted from another end called the front of the queue. You can look around and find many examples of the queue. In our day-to-day life, people waiting outside the ticket window of a cinema hall form a queue. In computer science, programs with the same priority form a queue while waiting to be executed. There are two basic operations on the queue, in queue and the deque. In queue means inserts an element at the rear end of the queue. Deque means deletes an element from the front end of the queue. Queue remember things in first out order. Good for fair ordering of actions. Let us understand the working of queue with an example. Let us take a queue that contains 4 elements A, B, C, D. As we know that addition operation is performed at the rear end and deletion operation is performed at the front end. To perform these two operations, we have to maintain 2 pointers, front and rear. Okay. Suppose we want to delete the items from the queue. Here you can see the front pointer is pointing to item A. Okay, the deleted item should be A. Okay, and now we increment the front by 1. Here you can see in the picture, now front is pointing to an element B. Okay. Now, suppose we want to add an element A. Okay. As we know, the addition operation is performed at the rear end. Okay. First, we increment rear pointer by 1 and put the value of E at that location. Okay. Now, in the picture, you can see now rear is pointing to A. Next, suppose we want to add an element F. Again, we increment the rear pointer by 1. Okay, and now put the value of F at that location. Okay, now you can see now rear is pointing to element F. Okay, now suppose another element is deleted. As we know, the deletion operation is performed at the front end. And here in the picture, you can see the front is pointing to P. Okay, now the deleted item should be P. And after the deletion, we increment the pointer front by 1. Now you can see in the picture, now front is pointing to an element C. This is the overall working of the queue. Now, next topic is implementation of queues. How will we implement queue in computer memory? So there are two ways we can implement queue in a computer memory. First is the array and next is the linked list. So let us start with how will we implement a queue with the help of array in computer memory. Let us take a size of queue is 4, means the capacity of queue is 4. Initially, the queue is empty. In that case, we set the pointer front is equal to 1 and pointer rear is equal to 1. Now, we are going to insert A. Okay. For this, before to insert A to the queue, we set front is equal to 0 and rear is equal to 0. And now put the value of A at the location pointed by the rear pointer. Okay. In the picture you can see A is placed at the location 0. In the same way, suppose we want to add B. In this case, first we increment rear pointer by 1 and place B at that location. So here in the picture you can see B is placed at the location 1. In the same way, we add the element C and D. After the insertion of the element D, and in the picture you can say the front is pointing to the first item, that is A, and rear is pointing to the item D. Okay, and rear has value 3 and front has value 0. Now suppose we want to add element E. Here we cannot perform the addition operation. Why? Since Q is full. So what is the condition of when we say Q is full? When rear is equal to max minus 1, we can say that Q is full. In that case, we cannot perform the addition operation. Okay. So what is the condition of Q is full? When the value of pointer rear is equal to max minus 1. Next, suppose in the first Q you can see front is pointing to the element A and rear is pointing to element D. Means front has value 0 and rear has value 3. Now we want to delete operation. We want to delete item from the queue. Okay. How will we delete? We access the element at the location pointed by the front pointer. Okay. And now we simply increment front by 1. The item deleted is A and now front is pointing to 1. As we know that the deletion operation is performed at the front end. Okay. Now again we want to delete an item from the queue. So in here you can see the front pointer is pointing to element B. Now B will be deleted and now front is pointing to the element C. Okay. Now again see item deleted C. Okay, now front is pointing to the element 3 and rear is pointing to element D. Okay. Now again we want to delete an item. Item deleted in this case is D. Why D? Because front is pointing to the element D. And we know that deletion operation is performed at the front end. Okay. Now after the deletion of D, the front becomes 4 and rear is 3. The value of front is 4 and rear is 3. Now again we want to delete an item from the queue. In this case you can see queue is empty and we cannot perform the deletion operations. The question is, when q will become empty? When the value of front is greater than the value of rear, we can say that the queue is empty, and in that case we cannot perform the deletion operation. Is it clear? Now we know when the queue is full, and we know when queue is empty. Is it clear? Now it is very easy to implement the insert item operation and delete item operation on the queue. Let us see the algorithm for insert item. So before to insert the item, we have to check whether the queue is full or not. The step one is, and here you can see this algorithm takes the one parameter, and that parameter is the item. And depending on the type of the element we want to keep on the queue, we have to declare the type of the item. In step 1, if rear is equal to max minus 1, in that case we cannot perform the delete operation. We simply give a message on the screen, queue is full, or we can say overflow queue, and go to step 4. Okay, if this is not the case, and if front is equal to -1 and rear is equal to -1, what it means? Initially queue is empty, and at this time we set front is equal to 0 and rear is equal to 0. If this is not the case, and when this is not the case, when queue has at least one item, in that case we simply increment rear by 1. Okay, step 3, we set queue followed by the rear is a pointer, and we put the item at that place. Next step, stop the algorithm. Next algorithm, delete item. Before to delete an item from the queue, we have to check whether the queue is empty or not. If queue is empty, we cannot perform the delete operations. Okay, when queue is empty, if front is equal to -1, or we can say front is greater than rear. Okay, in this case we write a message empty queue and go to step 4. Else we access the item pointed by the front pointer. Set item is equal to queue front, and next step we simply increment front by 1. Okay, next step, start. Next topic. Here I am showing you a portion of C program for array implementation of queue. First, as you already know, we generally use hex define. This is a compiler directive in the C language. Next statement, you can say hex define max 10. Here we declare the maximum size of queue is 10, and you can see there are two pointers, front and rear, and we set front and rear is equal to 1. Now next statement is a queue declaration statement. Depending on the type of information we want to keep in a queue, int followed by data type followed by the name of the queue. Here is the name of the queue is queue followed by the size of the queue. Next, to function insert item, and the return type of insert item function is void, and it takes one parameter, and type of that parameter, suppose assume is the integer. Next is the delete operation, and here the return type of this function is the int, and it does not take any parameter. Okay, this is the portion of the main function. Depending on your requirement, you can write the code here. Here I am simply write the insert item function. And how will we write the insert function? Insert item function and delete item functions. Okay. So insert item followed by the parameter is suppose item, and in the delete item we have to first we take a variable that takes the information from a function delete. So item is equal to delete item. Now here you can see the function insert item. It takes a parameter item. First statement, if rear is equal to max minus 1, we simply write a message overflow queue, or you can say full queue. Else if front is equal to -1 or rear is equal to -1, we simply set front is equal to 0 and rear is equal to 0, as we increment rear by 1. Next statement, q is equal to q, rear is equal to item. Now you can see this is the delete item function. If front is equal to -1 or front is greater than rear, we simply write a message empty queue or underflow queue. Else we access the element item is equal to q front, and after this we increment front pointer by 1, and next statement return item. Next is the linked list implementation of queue. In linked list implementation, let us start with how will we define a node of a queue. So here you can see, take a reserved word stacked followed by name of the stacked queue node, and here we have two fields. First is the item field, here you can see the information field, and next is the pointer. So each name node contains two information, two fields. One is the information and next is the pointer. Here you can see the struct queue. Here this structure has two pointers of type the pointer variables. Struct queue star front, struct queue star rear. And these are the function. Create queue of the return type is a struct queue, and it takes one parameter struct queue. Next is the insert item function. It takes two parameter, and return type is struct queue. Delete item takes one parameter struct queue star, and the return type is the queue type. Next is the display queue. This function is used to display the items of a queue, and return type is a void. Next is the peek struct queue star. Peek is similar to the delete item with one difference. In delete item, we increment the front pointer, but in the peek item, we do not increment the front pointer. This is the basic difference in peek and the delete item function. This is some portion of the main function. Depending on your requirement, you write the code here. Here I am writing simply the main function, create queue function, insert item function, and delete item function. You can say next is the display queue, next is the item peek queue. Create queue function, it simply set the queue front pointer and queue rear pointer null, and return is queue. Next is we are going to implement the insert item function. This function takes two parameter, two parameter. One is the type struct queue, a pointer type, and next is the simply integer data type. The first statement, you can see the struct queue node, the PTR. Here we are going to declare PTR is a pointer or type queue node. Now next statement, PTR is equal to struct node star memory allocate size of struct node star, means system malloc function allocates the memory space depending on the size of the struct node star, and set PTR to points that memory location. In the figure, you can see PTR is pointing to the allocated memory by the computer. Next statement, PTR item is equal to data. We simply put the data into the information field of the queue node. Next statement, queue front. Suppose we are going to insert the first item in the queue. In that case, queue front is equal to null. If this is the case, what we will do? Here we simply set queue front and queue rear to the PTR. Okay, and next statement, PTR next is equal to null. Okay, if this is not the case, means linked list has at least one element. In that case, queue front and queue rear will not be equal to null. Okay, it points to some nodes of the queue. If this is the case, what will we do? As we know, the addition operation is performed at the rear pointer. So here we said queue rear next is equal to PTR. Means queue rear next field points to the PTR. First statement. Next statement. Now we set queue rear to PTR. And you can see the queue front, we are not disturbing the queue front value. Okay. Next statement, queue rear next is equal to null. Next statement, return queue. So this way we can add the elements in a queue with the help of a linked list. Next is the delete item. Again, it takes the two parameters, and here you can see both parameters are the pointer type. Again, we declare PTR as a pointer variable of type struct queue node. Next is the PTR. We set PTR is equal to queue front. If queue front is equal to null, means queue is empty. Else, what we will do? We simply set queue front is equal to queue front next. Deletion means simply we change a queue front pointer by queue front next. Next step, we already set PTR to the queue front. Okay, now PTR is pointing to the queue front. Now start data is equal to PTR item. Now we have did our purpose. Now we free PTR. Okay. Next statement, return queue. So this way we can delete an item from the queue. Display means we want to see the all contents of the queue. Here simply we set PTR is equal to queue front. If PTR is equal to null, means queue is empty. Else we repeat the process of printing PTR data and PTR is equal to PTR next until PTR is not equal to null. We repeat this process of printing PTR data. And PTR is equal to PTR next until PTR becomes to null. Next peek. Here you can see if queue front is equal to null, queue is empty, else we simply return queue front data. Here you can see the queue front, the value of the queue front does not change. Next topic is types of queue. Linear queue, circular queue, Deque and priority queue. We have already seen linear queue. When we say queue, queue means a linear queue. Okay. Now let us start with what is a circular queue. Before to know the concept of the circular queue, let us review the linear queue with size 4. As we are already seen, initially when queue is empty, we set front is equal to -1 and rear is equal to -1. Suppose A is inserted, we set, suppose we are going to insert the first element, we set front is equal to 0, rear is equal to 0. And suppose B, C, D are inserted into the queue. What will become? In that case, front is pointing to front value has value 0 and rear has value 3. Is it clear? Okay. Suppose we want to insert an element E, we can say we cannot insert an element into the queue. Why? Queue is full and the condition is rear is equal to size minus 1. When rear is equal to size minus 1, queue is full, we cannot perform the addition operation. We have already seen this scenario. That is the case. Suppose we deleted an item. The first item is deleted and A will be deleted from the queue. Now, at that case, here you can see back. Suppose this is case, front is 0 and pointing to the item A and rear is 3 and is pointing to item D. And suppose at this scenario, we want to delete an item from the queue, so A will be deleted, okay? And now front is pointing to the element B and it has value 1 and rear has the same value 3. And we want to insert the item again at this place. We can say we cannot perform the addition operation. Even you can see in queue one space is vacant and despite this we cannot perform the operation of addition. One space is available but we cannot perform the operation of addition, and this is the drawback of a linear queue. Is it clear? Now, to overcome this drawback, we have two solutions. First, shift the elements to the left such that the vacant space can be occupied and efficiently used. But this scheme is a time-consuming process, especially when the size of queue is large. And what will be the alternative solution? Here, we use a circular queue. Next solution is a circular queue. So let us see what is a circular queue. Let us understand the operation of a circular queue. Suppose again, item deleted. Suppose front is pointing to 0 and item at that place is A, and we are going to delete an item from the queue. So A will be deleted, and what will be the situation? Front is pointing to element B and rear is pointing to element D. Is it clear? And now we want to insert an element at this place. We have already seen this scenario. Here we can say overflow condition still exists. We cannot perform the addition operation at this scenario. Okay. In circular queue, how will we utilize the vacant space? Vacant space is available, but we cannot perform the addition operation. But in a circular queue, if front not is equal to 0 and rear is equal to max minus 1, what will we do? It means that the queue is not full and we simply set rear is equal to 0 and perform the insert operation. Now here in the picture you can see front is pointing to element B and we can insert the item at location rear is 0. Here you can see now rear is pointing to element E. Okay. And here you can see when there is no space available in the queue, only in that case queue is full. When front is equal to 0 and rear is equal to max minus 1, in that case we can say the queue is full. Other case, suppose this is the case. Front has value 1 and rear has value 0. Okay. Now B and C deleted. Front is now pointing to D and rear is pointing to E. Again we perform a delete operation. D will be deleted from the queue, and this is the scenario. In that case, we delete D, and when the front is equal to max minus 1, we simply set front is equal to 0. As we know, after the deletion operation, we increment a front pointer. But when front is equal to max minus 1, we simply set front is equal to 0. Okay. So here we have seen how a circular queue is working. How circular queue is working. And what is the when the queue is full and when queue is empty. Based on these two cases, let us check this scenario. If front is equal to 0 and rear is equal to 0, and suppose item is deleted, what will happen? In that case, queue becomes empty, and when queue becomes empty, we simply set front is equal to -1 and rear is equal to -1. Is it clear? Keep these things in your mind, and now we are going to implement how will we write the insert item function in a circular queue. What is the when queue is full, when front is equal to 0 and rear is equal to max minus 1, in that case queue is full. So before to add the element into a circular queue, we have to check this condition. Next, if front is equal to -1 and rear is equal to -1, we simply set front is equal to 0 and rear is equal to 0. Else, if rear is equal to max minus 1 and front not is equal to 0, in that case we set rear is equal to 0, else we increment rear by 1. Next step, set queue rear is equal to item. Next step, stop. Let us see delete item algorithm. If front is equal to -1, we can say queue is empty. If this is not the case, we simply set item is equal to queue front. We access the item pointed by the pointer front. Next step, if front is equal to rear, we have already seen in the example, in that case, we set front is equal to -1 and rear is equal to -1. As if front is equal to max -1, we have already seen this case also. In this case, we set front is equal to 0. Else, we increment front by 1. Okay. Now it is very easy to write a C program for a circular queue. Okay. Next up is the Deque. It is a list. It is a special type of queue in which elements can be inserted or deleted at either end. It is also known as head-tail linked list or double-ended queue. Here you can see insertion operation can be done at the both end and deletion operation can be done at the both end. It is a list. It is a special type of queue. Implementation of that circular array, and next is a circularly doubly linked list. With help of these two ways, we can implement a Deque in a computer memory. There are two types of Deque: input restricted Deque and output restricted Deque. In input restricted Deque, insertion operation can be done only at one end, but the deletion operation can be done at the both ends, front and rear. In output restricted DAC, insertion operation can be done at the both end, but the deletion operation can be done at only one end. Let us see the when the queue is full in DAC. When front is equal to 0 and rear is equal to max minus 1 R. When front is equal to rear plus 1, we can say queue is full. Next, when queue is empty, when front is equal to minus 1. So here, next we are going to write a 4 algorithm, 2 for the delete operation and 2 for the insertion operation. So delete left algorithm, delete right algorithm, insert right algorithm, and insert left algorithm. Insert right. If front is equal to 0 and rear is equal to minus 1, or front is equal to rear plus 1, we have already seen this case, we can say queue is full. Otherwise, if front is equal to minus 1, we simply said front is equal to 0 and rear is equal to 0. Here we are going to perform the insert right operation. Means we are going to perform the insert operation at the rear end. Okay. Now, if rear is equal to max minus 1, we simply set rear is equal to 0, else rear is equal to rear plus 1. Next step, DAC rear is equal to item. Next, stop. Insert left. First step is similar to the insert right. Next step, similar to the insert right. Here the difference arises at this place. Here in the previous algorithm insert right, you can see in the else part we have written rear is equal to max minus 1. Okay, and here what I have written, if front is equal to 0, we set front is equal to max minus 1, else front is equal to front minus 1. Okay. In the insert right, we use the pointer rear, but insert left, we use the pointer front. This is a difference, one of the difference. Okay. Next is the delete left. If front is equal to minus 1, queue is empty. Which otherwise, next step, set item is equal to Deque front. If front is equal to rear, we simply set front is equal to 0 and rear is equal to 0. Next, if front is equal to max minus 1, then set front is equal to 0, else front is equal to front plus 1. Next, stop. Here again, you can see delete right operation. In delete left, we use the pointer front, but in delete right, we use the pointer rear. Okay. Step 1, step 2, step 3 is similar with the delete left algorithm. Difference arises at this place. If rear is equal to 0, we set rear is equal to max minus 1, else rear is equal to rear plus 1. In delete left, you can see in the place of rear, a front pointer is used, but delete right, we use the rear pointer. Okay. So with the help of these algorithms, again you can implement you can implement a C program. You can able to write a C program, and it is very easy to write. Okay, I'm not going to write a C program for these 4 algorithms. Next topic is a priority queue. What is a priority queue? Priority queue is a collection of elements such that each element has been assigned a priority number. So what is a priority queue? It is a collection of elements such that each element has been assigned a priority number. And the priority number is used to determine the order in which elements are processed. There are two types of priority, ascending priority queue and next is the descending priority queue. Ascending priority queue is a collection of elements. Next point, elements are added in arbitrary way. Next, it allows the lowest, it allows deletion of lowest insertion time value element. And in descending priority queue is same as the ascending priority queue with difference that it allows deletion of highest insertion time element, insertion time value element. Rules of processing elements of priority queue. An element of higher priority is processed before an element of lower priority. Next point, two elements of same priority are processed according to the order in which they were added to the queue. First come, first served. The priority of process may be based on CPU time or importance of one process over another. So depending on our requirement, we can assign the priority to the process. Representation of priority queue. There are three ways we can represent a priority queue: linked list, array, and next is the binary heap. Here we discuss only the linked list and array. Binary heap we will discuss in the next video. In linked list representation, let us see linked list representation of a priority queue. In this, each node has three fields. First is the information field, next is the priority number, PRN, and next is a link field, that is a next field. A node A precedes a node B in a linked list when A has higher priority than B, or when both had the same priority but A was added to the list before B. Here we assume lower the priority number, higher the priority of the job or a process or the item. Next, insertion algorithm. How will you add a item in a priority queue? Step first, traverse the list until finding a node A whose priority number exceeds priority of the item to be inserted. In this case, insert item in the front of node A. Step second, if no such node is found in step 1, then insert item as the last element of the list. Next step, stop. Let us consider the following priority queue. Suppose the priority queue contains three items A, B, and D. And priority of A is 1, B is 2, and D is 5. Now suppose we want to add an item C having a priority 4. Is that clear? Now, we take two pointers PTR and PTR previous and set these two pointers to the head of a priority queue. First step. Next step, we increment PTR and PTR previous. Okay, moves PTR and PTR previous in a linked list until PTR becomes null. Okay, or if PTR priority greater than new node priority, In that case, PTR points to that specific node. Here we simply set PTR previous next to new node and new node next to the PTR. Case second, if a node does not exist in a priority queue having a priority greater than new item priority. In that case, we simply add new node at the end of the list. Means PTR next, we set PTR next is equal to new node. Is it clear? So this way we can implement the algorithm to add an item into the priority queue. Let us see the deletion operation. Here we simply set item is equal to head info, delete first node from the linked list, process the item, and next step stop. Here suppose again consider a priority queue having three items A, B, D having a priority 1, 2, and 5. And suppose we want to delete an item from this priority queue. We simply set PTR is equal to head. This is the statement. We set head is equal to head next. In the picture you can say now head is pointing to the second element in a priority queue, and we simply remove the PTR. Okay. Now you are able to write a complete algorithm for deletion of item in a priority queue. I have left this portion again. Next is the array representation of a priority queue. Keep some point in your mind. For each priority number, we use a separate circular queue. Means, suppose a system have 4 priority number 0, 1, 2, 3. Means we use 4 priority queue, priority queue 0 means this priority queue contains all items having priority 0. Next, priority queue 1, priority queue 2, and priority queue 3. Priority queue 3 means this priority queue have all elements, all jobs, all process having a priority value 3. Okay, it is clear? Next point. As we know, each queue must have a pair of front and rear pointers. Is it clear? In this specific example, we have 4 priority queue, means we have 4 front values and 4 rear values. To keep the front values, we take a one-dimensional array of size equal to the number of priority in the system. Here in the picture you can see there are 4 priority number. Therefore, we take a one-dimensional array of size 4 to keep the values of front of all queues. In the same ways, we take a one-dimensional array to keep the values of rear Size of rear again is the number of priority in the system. Is it clear? For 4 priority number, we have to use 4 priority queue. Priority queue 0, priority queue 1, 2 and 3. And we also take 2 one-dimensional array to store values of front and rear pointers. Is it clear? Is it clear? Now, next point. For this purpose, instead of taking the 4 priority queue, we take a 2-dimensional array. Okay? And the number of rows in an array is equal to number of priority, or you can say number of priority queue in the system. Suppose we have 4 priority number, so we take a 2-dimensional array having 4 rows. Okay? Is it clear? Next point. And assume the size of circular queue is max. And here max is 5. Means number of columns in a 2-dimensional array is 5. Is it clear? Okay. Okay. Now, let us consider 2-dimensional array. We know that the row 0 represent the queue, priority queue 0, row 1 represent a priority queue 1, row 2 represent a priority queue 2, row 3 represent a priority queue 3. Okay, and the columns is a capacity of each queue must have the same capacity. Okay, now you can see a 2 one-dimensional array. One is the front one-dimensional array and next is the rear array. Okay, so there are 3 arrays. Okay, one is the 2-dimensional array and 2 are the one-dimensional array. Okay, suppose we want to, let us, before to see the operation, in 2-dimensional array you can see the 0th row of 2-dimensional array contains a value and item A at the location 0, 2. So how will you get the front and rear pointer value of Q0? For this purpose, you simply go the front array and the rear array. Here you can see the A is placed at 0, 2. Okay, 0, 2. For this, you simply go the front array at location 2, you will get the front value. Is it clear? And at the rear, you can get the rear values. Is it clear? Here you can see. Okay. For Q0, you simply see the front 0 and rear 0 gives the front value and rear value of Q0. Front value and rear value of Q0. Okay. For Q1, you simply go front 1 and rear 1. What is the front 1? You can see front value is 0. And what is the rear 1? Rear 1 value is 2. Means for Q1, front is pointing at location 0 and rear is pointing at location 2. Is it clear? Now, Suppose we want to insert item R with priority K is equal to 2. How will we insert R? Step 1, we set rear is equal to rear K. What is the K? Priority K. We simply look the contents of rear 2. And what is the contents of rear 2? Is 4. Okay, so rear is 4. Next step, we set rear is equal to rear plus 1 mod max. So 4 plus 1 mod max, max is 5. So 5 mod 5 is equal to 0. Means we get the value of rear is equal to 0. Next, we simply set QK. What is the K? K is a priority. Priority is the priority of the item R is 2. So we simply said Q2 and followed by what is the value of rear? Rear is 0. We simply said Q2 0 is equal to item. So with the help of these 3 steps, we can insert an item in a priority queue. Okay, is it clear? Now, let us see the delete operation. Suppose we want to delete an element from the priority queue. Step 1, search the first non-empty queue. Let us see what is the first non-empty queue. You can see the priority queue 0. Since this queue has at least one element A. Okay. Now next step, set the front element of the first non-empty queue. How will we get the front element? We simply set front is equal to front K. And what is the K? K is here 0. The first non-empty queue is 0, means K is 0. We simply find the value of front by putting front 0. And what is the front 0? 2. So we get the value front 2. Next step, item is equal to QK front. What is the K? K is 0. The Q 0. And what is the front value? Front value is 2. So Q02 and what is the Q02? A. So A will be deleted from the queue. Okay. Is it clear? Suppose we want to delete next element. Okay. So what is the first step? Search the first non-empty queue. In this case, suppose A is deleted, the Q0 is empty, then we have to search the next non-empty queue is what? Priority queue 1. Next step, set front element of the first non-empty queue. Front is equal to front K. And what is the value of K? K is 1. And front K, you can see 0. Front 1 is K. K means here 1. So front 1 is 0. Okay. Now item is equal to QK front. QK, K is 1 and front is 0. So Q1 and 0. And what is the value of Q10 is B. Now next item will be deleted from priority queue is B. In this way, you can delete the items from the priority queue. Okay. In a nutshell, we can say to delete the item from a priority queue, find the element with the smallest I such that front I is not equal to null. Okay. So this way we can perform the addition and deletion operation on a priority queue. Is it clear? These are the references. You can take help of these reference books also. Any questions? Thank you very much.